Hi, I'm Mrs. Scarpel, and we're going to take a look at equations of lines as well as graphing lines. So here we have a line, the red line, and there's 2 points in blue that are on the line that have been plotted. And we're going to write the equation of this line, but before we do, we need to identify some information that we know about this line to help us write the equation for it. One piece of information that we should be able to identify is the y-intercept. The y-intercept is the point where the line crosses the y-axis. Now notice I said the point, and whenever we write the location of a point, we're going to write it as an ordered pair. So the point where this red line is crossing the y-axis is at the point 0, 3. So the y-intercept is at 0, 3. Something else we can determine from this line is the rate of change or slope. And as Mrs. Kraft mentioned in a prior video, if we read from left to right, I'm going to go from my y-intercept to this other point that's been plotted in blue. And I'm going to draw myself a slope triangle, a right triangle that goes from the y-intercept to that blue line. So my vertical change is a -2. And my horizontal change is 1, 2, 3, 4, 5. A positive 5 because I went to the right. So my slope, my change in y over change in x, or delta y over delta x, is -2 over 5. So those are 2 things I know about this line. Now something else you may recall, one form of an equation of a line is slope-intercept form. And the reason it's called slope-intercept form is because in that form we can identify the slope and the y-intercept of a line. And the slope-intercept form of a line is y equals mx plus b, where m is the slope, or our rate of change, and b is the y value of the y-intercept. So if we take this information that we have found about this line that was graphed and use the slope-intercept form, we can write an equation of this line that will look like this. Y equals, the slope is -2/5 x plus 3. And we have the equation of our line. We have the slope of -2/5 and the y value of the y-intercept is +3. So that's writing the equation of a line given the graph of a line. But how about, when given the equation of a line, graphing the line? Well, just like the last one, let's identify what we know. We know the slope, which is delta y over delta x, or change in y over change in x, is going to be 3/5. Because in y equals mx plus b, m is our slope. So the coefficient of our term that has x is always our slope. And then the plus b is the y value of our y-intercept. So I can also identify that here. Now notice this is y equals mx plus b, but we have a minus 4. That means that our y-intercept is going to be the point 0, negative 4. Because it'd be like adding a positive or adding a negative 4 to our equation. So if I have my slope and I have my y-intercept, I can actually graph my line just from those two pieces of information. I can plot my y-intercept. I know it's at 0, negative 4. And I know that my rate of change, my delta y over delta x, is 3/5. And it doesn't matter which point I start at on my line, that's my rate of change all the time. So if I start with my y-intercept, which is a point on my line, and I count 1, 2, 3 for my change in y, and then we have a positive change for the horizontal, 1, 2, 3, 4, 5. I have another point at 5, negative 1. And just for accuracy, I like to do this at least one more time. Up 1, 2, 3, 1, 2, 3, and to the right 5, 1, 2, 3, 4, 5, plus 5. So I should have 3 lines, or 3 points, excuse me, that line up that I can graph a line through. And notice I have arrows on each end because the line continues in each direction. Something else I'd like to point out here is if I didn't have enough room to do up 5, right 3, my slope could also be written as negative 3 over negative 5, because a negative divided by a negative is also positive. So using this line, I'm going to show you that if we had done a vertical change of down 3, left 5, we would have found yet another point on our line. So sometimes we need to think backwards when graphing if we don't have room on our graph. Most of the time, I think we can just generally think left to right, but sometimes we do have to think backwards, down and left. So let's put this in context. Your family is moving to a house across town and will need to rent a moving truck to move all your belongings. The rental company charges $50 plus an additional $20 for every 25 miles the vehicle is driven. What equation models this situation? Well, we have charges $50 plus. So in my mind, I'm envisioning 50 plus something. And it's $20 for every 25 miles. $20 for every 25 miles the vehicle is driven. So that gives me a rate. So I'm going to make a note here that my rate equals $20 for 25 miles. And I'm going to simplify this because I know that 5 goes into both of those, so I can simplify that fraction. I can simplify that down to $4 for every 5 miles. And I could simplify it even further. If I wanted it to be per mile, I would take the $4, divide it by 5 miles, and I would end up with 80 cents per mile. So that's my rate. So we have 50 plus 80 cents per mile. So if I write an equation, y equals $50 plus 0.8 per mile per x. So let's make a graph of this. Well, if it's per mile and we're saying x is the miles, we should label our graph that our x-axis is the number of miles and that the y-axis is the cost. And we need to determine a scale. Since we're talking about every 25 miles and we also had it at 5 miles, let's see here, 10, 20, let's do our scale by 5s for our miles here. 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. And then for our cost, we know we're starting at $50. So let's do this by 5 as well, I think. So $10, $20, $30, $40, $50, $60, $70. And I'm going to put in parentheses that cost is in dollars. And the reason I chose to go with the same scale is because I'm going to use this for fifths to help me with my graphing. So my y-intercept is at 50. And since my scale is the same, if I count up 4, 1, 2, 3, 4, I can count to the right 5. Oops, I didn't count 5. I thought it looked a little off. Good thing I counted again. And let's see if that goes with this. It increased $20, so we went up $20 for a 25-mile increase. And here's my line. Oops, I'm going to use an actual line just because I'm not necessarily the straightest drawer. And that's what the graph would look like if we start both axes at 0 and we use the exact same scale. Now, could I adjust the scale? Yes, I would, but I would have to be careful finding my slope, looking at my, I wouldn't necessarily be able to just count up 4, right 5. I'd have to make sure that I'm doing an increase of 20 over an increase of 25 to make sure I'm graphing it correctly.